everyone. Welcome to your Play Posit lesson for the day. We're going to be covering 3.03 through 3.04 in your OMHS. Go ahead and grab your notes if you're using the guided notes that I provided and have your OMHS Play Posit graded assignment open. Let's get ready. Just a few announcements before we move forward. This Friday, super excited, we have a virtual outing for you guys. It's called Farmers Market. And it says, calling all farmers, gardeners, bakers, woodworkers, crafters, come show off your hard work at the virtual farmers market. Do you raise animals? Do you bake bread, cake, cookies, grow plants and vegetables, or make crafts that you would like to share? We would love to see them. So all submissions are due by October 28th at 5 p.m. For the submissions, you're going to want to use the link below. Now, I realize you cannot click this link right now because this is a video, but I'm going to put it in one of the Play Posit questions. So it's going to pop up for you, and if you want to submit your pictures of your craft items, we would love to see them. And of course, you guys, if you do not have anything to submit, or maybe you don't want to share, but you still want to come and see your schoolmates' submissions and just hang out, we would love for you to come. Everyone's invited. And you'll see that session link on your calendar for next Friday at 11 a.m. Cool. Our next announcement is about another session we have coming up for the 7 mindsets. So a big thing here is that it says that 10 students who attend will randomly be drawn for an Amazon gift card. Kind of another little incentive for you guys to join us. That's going to be also this Friday, but it's going to be at 1 p.m. So look for that Zoom session on your schedule as well. I'll be at both of these. I hope to see you guys there. So I know we've talked about this twice now already in classes, and I'm sure you've heard it from your other teachers as well. But just don't forget that our first end date is approaching. It is November 6th at midnight. So from here, we have 2 weeks officially until this date. And just remember that after this date, you will not have access to any assignments that were assigned prior to. So you want to make sure you complete any missing assignments that you might have zeros showing for, and then use this opportunity to review and retake any low graded assignments. As always, you guys, I'm here to help you. If you need anything at all, we have some extra algebra sessions on your schedule for help. And I can also look at setting up any one-on-one sessions. So please reach out if you need anything at all. Okay, big announcement. We have our second extra credit opportunity. This one just kind of fell in my lap. I did not have it planned, but I went to a Desmos session. There's one every Thursday, and I went and they showed this crazy fun pumpkin carving activity. I had so much fun doing it myself, and I'll share my pumpkin with you guys when we're done. But if you would like to participate and create your own pumpkin, this is on your plan for today. And it's also an announcement. So you have that link that you can click when you go into our OMHS. So you'll want to click the link. You'll choose continue without signing in. And you should see this screen here and just click there. You do not have to sign in or create an account. You can if you want to. You're certainly welcome to create a free Desmos account, and it will basically save all your activities in that account that we do throughout the year. But you do not have to. And then there'll be an example on the first slide for you to kind of get used to how the tools work. And then if you click to slide 2, you'll be able to create your own. So be creative, have fun. You'll get to choose the color of your pumpkin and everything. And that is going to be due by October 30th, so this Friday at midnight. Of course, I don't want you guys carving pumpkins at midnight, but you know what I mean. It's due by then or before then. And when you get into the activity, just know that you don't have to submit it or save it or anything like that. Desmos auto saves. So as you're doing your work, it automatically saves it. And so I'll be able to access it to give you your points. Just make sure that you use your first and last name so that way I know whose pumpkin I'm grading. All right, so today we're just going to continue to weight lift our brain and work towards graphing equations and writing equations, kind of like wrapping up our writing equations section here. And I know we've talked about this before. I don't know if I've shared this exact slide with you guys. I think I have some of you, but I put it in here again just in case. Anything that we do, anything worth doing, right, it's going to take some practice. I always say, like, this ballerina didn't wake up one day and just automatically be able to leap through the air like that. We all might have some natural abilities at things, but to become better, we need to practice. So I don't like to say practice makes perfect, practice makes better, and all we can do is keep trying to be better. If I didn't tell you this yet, this is my brother-in-law Henry over here. He is a national champion in yoga. He went to the national championship in China. I think it was 3 or 4 years ago now. That's him. It's crazy. He lived in New York for a while, and now he lives in California with his wife, and they go traveling around to different yoga studios because he's kind of world renowned now. But he did not wake up and just be able to twist himself like that. He had to practice. So we're going to practice our math just like all these people practice their other things, just like you guys probably practice your hobbies as well, or athletics activities. So let's do it. All right, here's the first kind of example we're going to do. Write an equation of a line that passes through these points. So we know that there are 3 different types of lines, right? There's y equals mx plus b. That's our slope-intercept form. There's y minus y1 equals m, x minus x1. That's our point slope form. And then we have the basic, right? The standard form in alphabetical order. So in the end, it wants us to give all 3 forms of the line. But the only things that we're given are 2 points. So if we're just given 2 points, it's helpful to look, okay, can I use any of these and sort of just plug them in? And just like I've shared with you guys before, there's more than one way to solve this problem. This is the way I'm going to do it. You might do it another way, but let's just see if you get the same answer. So because we have 2 points, I'm going to find the slope. We know that the slope formula says that the change in y over change in x. So change, meaning the difference. And also sometimes we see it written as delta y over delta x, change in y over change in x. I'm just going to label my points here with those little subscripts. And that just kind of helps us keep everything straight. So the little subscript of 1 just means that's point number 1. And here's point number 2. So once you have it labeled, kind of just plug it in, right? y2 is negative 3. y1 is 0. x2 is 0. And x1 is negative. Wait, did I mess up? Oh, there's just lots of the same numbers. Let's make sure we did this right. y2 is negative 3. y1 is 0. Perfect. x2 is 0. x1 is negative 3. Okay, we're good. So now we can do this math. Negative 3 minus 0 is negative 3. And then a negative times a negative is a positive. Now you're pretty much done, but it's a good idea to go ahead and simplify if you can. Negative 3 divided by 3 is negative 1. All right, so we found m. So now that we have m, we could probably do plug and chug into one of these formulas, right? This one has an m, and this one has an m. Which one should we try first? Well, because we also have some points, I'm thinking we should do the point slope form. Because check it out, we have a point and we have the slope. So let's take it to the point slope form. So that means we're going to have y minus y1 is 0, right, from our labeling. M is negative 1. X1 is negative 3. So just be careful with those signs. Whoops. Oh, I hate when my pen does that. Sorry. Be careful with those signs. We have a minus in the general form, and then the point has a negative. So let's just simplify this. Y equals, well, that's the first form, right? We did it. We put it in point slope form. But if we simplify it, let's look. Negative 1, it's x plus 3. We can keep going, right? Because we're trying to get it into the other 2. So we want to get y by itself, which we did. But now let's sort of simplify this out. So we would get we would distribute and get negative 1x minus 3. Ta-da! We just turned that into slope-intercept form. So now we have the two forms. I'm going to label these to match. We did point slope and we did slope intercept. Now we just need to get standard. So it's up to you. You could do it from either form. I'll just go from this guy, slope intercept form, and we want to make it look like number 3. We want to get the x term on the left, the y term on the left, and just numbers on the right. So we just have to move the x over. So we just have to do that inverse operation. So we would have 1x plus y equals negative 3. There it is. There is our third form of a line. That one happens to be standard. Cool, that was fun. Don't forget, at any point, you guys can pause this recording if you need to slow me down or you want to try to put in forms by yourself. That's the beauty of a recording. All right, let's try this example. Graph the line using slope and y-intercept. So they gave us the equation of the line, and they want us to put it on the graph. So let's pull off the important information. What is the slope? So this form, look, it's in slope-intercept form. Y equals mx plus b. This is the one we're kind of used to. It's also really helpful. So the slope m, that's the coefficient of x. That's the number in front of the x. So it's 1/7. And the y-intercept is 3, right? But we're going to write it as a coordinate point of 0, 3. So now to graph this, we can use these two pieces of information. So all we're going to do is we're going to put a point on 0, 3. And hopefully this feels familiar. You guys have graphed before. We've done it in here a little bit. We're about to do it a lot more next class too. So you start at the origin, and we went 0 in the x direction, and then up to 3. Be careful of the scale here on this graph. They're going by 2. So 3 is right there in the middle. All right, now we're going to use the slope. Remember, slope is rise over run. Rise meaning we're going to go in the y direction. Run goes in the x direction. So we're going to rise 1 unit and go over 7. 1, 2, 3, 4, 5, 6, 7. And put another point. We can go in the other direction too, the negative direction, down 1 and over 7. And we can keep doing that as many times as you guys want to. I'm probably going to stop here. 3 points is enough to give me a line. 2 is probably enough. Let's see if I can get a pretty line in here for us. Approximately. It's pretty slopey, right? Hey, that's not so bad. I'm very proud of that line. Very proud. All right, so the steps are we put a dot on the y-intercept because we know that graph is going to cross the y-axis at 0, 3. Put it there. And then we used the slope to finish out the line. 1 over 7, up 1 over 7. And we could keep going. Up 1 over 7. You can see it would be about on the line. So just a good check, when you look at the original, it's a positive slope, right? 1/7 is positive, so that means going left to right, if we were to take a walk on the line, we would be going up. The line is going up because the slope is positive. If the slope was negative, the line would be going down. All right, let's graph this function. This one says to specifically use intercepts. So let's try that. If you look at this line, what form of an equation is this line in? It is in standard form. Remember, it's very basic, very blah. A lot of people think it's not very useful, but in this example, it actually is because they want us to use intercepts. So remember, the x-intercept is when y equals 0, and the y-intercept is when x equals 0. So let's just plug in 0 and see what we get. So instead of y, we're going to have 0 for this one. There we go. So this basically goes away, right? 9 times 0 is 0, and x equals -9. See how easy that was? That's why standard form is helpful with intercepts. So our coordinate point is -9, 0. There we go. All right, let's find the y-intercept. So we're just going to plug in 0 for x. And then we're going to get what is y. So we have -9y minus equals -9. Divide by -9. This one takes a little bit more steps. Y equals 1. So we have 0, 1. Perfect. Now we have 2 points. 2 points is all you need to graph a line. I know in the last example we did 3, but that's just because I wanted to draw a pretty line. You guys, we could have done it. We could have connected the dots with 2. Have you heard that saying, the straightest or the shortest distance between 2 points is a straight line? I think that's a song too. So yeah, all we need is 2 points. Let's graph it. So -9, 0, there's our x-intercept, and 0, 1. There's our y-intercept. Now we can go ahead and graph our line. Let me put in a pretty line. Whee! Yay! Whoop, there we go. I'm gonna make it darker. There we go. Cool. There's our line graphing our line using intercepts. Not too bad. All right, let's look at this example. Sorry about that. A line with a slope of 9 passes through the point 3, 5. What is the equation in point slope form? So they straight up tell you. They want you to give it to them in point slope form. So I'm going to write our general form of point slope form. That's a mouthful. There we go. Here's our point slope form. Again, it's called point slope because look, there's a point, x, y, and there's the slope. Remember, this x and this y, that's just the general x and y that's in the equation. That represents all the possible x and y values that make up the line. This x sub 1 and y sub 1, that's a specific point on the line. So that's why it's labeled differently. All right, let's do it. All we have to do is label our point they gave us and plug it in. Remember, what is 9 equal? 9 is the slope, so that's m. So we're going to have y minus y1 is 5, m is 9, and x1 is 3. That's it. We're done. It says use the specified point in our equation. Write our answer using integers, fractions, and improper fractions, which we did. These are integers. And to simplify fractions if necessary. We did not have to do any of that. They are just integers, so we're good. That's it. And it wants us to leave it in that form. Done. All right, let's try graphing this function. It says click to select the points on the graph. So you guys are going to see questions like this, most likely in your OMHS, but also on the SOL where they're interactive. You're going to have to actually click on the graph. So if you look at this, what form of a line is this in? Hopefully you're seeing that this is in point slope form. Look, here's the point, and then here's the slope. So again, there's going to be a few ways to graph this, and it's kind of up to you how you want to do it. It doesn't tell us how. Some people even like to go very old school and make an XY table. I mean, that's fine. It always works. But since we now know this special form, let's go ahead and use that. So let's go ahead and use the form that we know. So this is in point slope form. I'm going to write the general, I'm sorry, this is in, yeah, point slope form. I'm going to write the general form up here. Point and slope, because there's a point and a slope. So we can pick off the slope. The slope is 7/3. And we can pick off a point on the line to use. And remember, when we do that, we want to take the opposite sign. Because the general form has a negative in each place, we want to take the opposite. So since this is -2, we're going to take a 2. Since this is a +6, we're going to take a -6. And you could always double check yourself. Like if you were going to put this point back into this equation, watch what would happen. We would take a +2 and put it right in there, and it would be negative. We would take a -6 and put it in here, and it'd be a negative times a negative would give us that positive. All right, so now we're kind of back to the other example that we had where we graphed that y-intercept first. So here, let's graph the point first. It's not the y-intercept, but it's still a point. So we'll go over 2, down -6. So we know the line is going to go through that specific point, and then we're going to use the slope. So we'll go up 7, 1, 2, 3, 4, 5, and over 3. Here we go. Now I'm going to connect the 2 dots and give us a pretty line. And this line is going up from left to right. Now let me see. I just need to swing it a little. There we go. To make it go through the 2 points. There we go. So this slope is positive, so it's very steep. You can see that. And because that is an improper fraction, that does even make sense because it does make sense. Because this would be, if we thought about it, this would be 2 and 1/3, right? So that's a steeper slope. We would never put it in this form to actually use it as a slope. I was just kind of showing you that's why the line is so steep, because it's a larger number, bigger than 0. All right. Let's look at the next example. It says, look at the graph. This time we're going to go from the picture to the equation. What is the equation of the line in point-slope form? Use the red point in your equation. Write your answer using integers, fractions. Okay, we got it. So it's telling us they want us to use that red point as the point. So I'm going to write this a little bit bigger up here. So they give you the general form. That's nice. And they want us to plug in the values that we know. So we're going to need a point, and we're going to need the slope. So it tells us they want the red point, so we'll count over. So that's -5, -1. And then the slope. Remember, slope is rise over run. So let's try to get from the red dot to some other dot. This one looks good. It's right on the line. It's best to pick a point right on the line so you don't have to deal with fractional parts. Like, see, if we tried to pick this point, it's kind of in between grid marks. So you want to pick a point that's right on an intersection of a grid mark. Even this one. So let's see, we're going to go up 1 over 3. Up 1 over 3. We can keep testing. Up 1 over 3. 1 over 3. See? Perfect. All right, so now we have the 2 pieces of information we need. So we'll put in the slope, 1/3, and the point. So remember, this is x and this is y. X goes over here, and y goes over here. So it looks like that's probably all you would do for this one because they want you to like insert the number. But like if we were working it out, I'd want to simplify it, right? So negative times a negative is a positive. Negative times a negative is positive. But yeah, this one says to just insert the value. So because that's y minus, you would put a -1 here, 1/3 here, and a -5 there. Perfect. Multiple choice. Which equation represents the line that goes through those 2 points? Now there's so many ways to solve this problem. I was thinking I could show you on the Desmos graphing calculator. So check it out. I went to Desmos and I put in the 4 equations just as it was given to me in the 4 separate lines here. And then I put in the 2 coordinate points. So you can see that right now on my screen are the coordinate points. You can click them and they'll show you their values. And then over here on the left, I have these turned off. To turn it on, all I do is click on this little circle there and see it graphed the line. So you can see the first A option only goes through the red point. So that's not going to work, right? It needs to go through both points because that's what it wants. So I'm going to turn that off. We have to find the one that goes through both points because it said, let's go back and look, which equation represents the line that goes through the 2 points? Okay. Option 2, oh, that only goes through the first point. So that's not going to work. Ooh, option 3, that's letter C for us. That does go through both points. Let's just check out number 4, and that does not go through either. So our answer is C. So I would recommend that you pause and also try this on your own so you get used to entering in these values into the calculator and kind of playing around with it a little bit. So our answer is C. Now the other way you guys could do this is you could certainly plug in these values into each of those and see which one makes it true. Like I'll show you for this one, we would plug in 4 for y and -4 for x. And if it goes through the line, that means it's a solution to the equation. That means it's going to work. It's going to make sense. So here, reviewing fractions, we'll do the top times the top, bottom times the bottom. And you get 4 divided by 2 is 2. 2 plus 2 is 4. So sure enough, it works. It's a solution. We can check the second point. We would have to, right? Because it wants both of them to work. There we go. Half of 8 is 4, and that's a negative. And then we get -4 plus 2 is -2. So sure enough, they both work. So that's another way you could have done it. It does take a little bit longer, right? Because you'd have to check for all of them. Another way you could have done it, you could have found the slope between these 2 points. And you would have found that it was -1/2. And then plug in one of the points and see if it's true. So that's just another idea. There's so many ways to solve problems in this class. That's what makes it so much fun, I think. Whatever your brain sees first. All right, last one. Look at this graph. Write the equation of the line. So I know we've briefly talked about horizontal lines. What kind of slope does a horizontal line have? What's the steepness of the line? It's a very special slope. The slope is 0 because that slope is not going up or down. It is staying constant, right? The other special slope we have, remember, is a vertical line. Remember the slope of a vertical line? That is undefined. Because if you were standing on it, you would just fall right off. The slope of a vertical line is undefined. We have a horizontal line here, so the slope is 0. All right, remember to write an equation of a line, we really only need 2 things. Y equals mx plus b. We really only need the slope and the y-intercept. So if you can get those 2 things easily, my opinion is this is probably the best route to this form of a line. So we have the slope. Now we just need the y-intercept. Okay, here's the y-axis. It goes through 9. It goes through the point 0, 9. All right, let's just plug it in now. We have y equals the slope is 0 times x plus the y-intercept of 9. Now when you're plugging it into the slope-intercept form here, remember that b value is just the y value. So that's it. You can leave it like this. It's more common for you to see it like y equals 9. So sometimes people get a little uncomfortable with lines like this because there's no x's. Like, where's the x values? Well, there are none, right? If you look at this graph, it's only y values. It's only going through y equals 9. So every single coordinate point is going to have the y value of 9. Now, I don't mean there are no x values. That's not what I mean. I just mean that the y values are always going to go through 9. So like if we made a chart for this, no matter what value is on the left, this will always be 9. So 0, 9, 1, 9, 2, 9, 3, 9. You can see if we had a coordinate point 2, 9, 4, 9. So no matter what x value you put in, you'll always get 9. That's why we don't really write the x. But you could leave it like this if you wanted to. You could. And you could always confirm in your Desmos too. Let's try it. I'm just going to X these to clear them. And I'm going to type y equals 9. And you don't see anything, right? You're like, where's my line? Well, if you look at the grid mark here, we only go up to 6. So you have two options. You can click and hold and drag the graph around. See? Or you can zoom in and zoom out until you see your graph. There it is. So if you click, you can kind of drag it around until you find your line. All right, you guys, thanks so much for watching and for following along. Please check your email. I sent an email this morning, very important, has a lot of good information in it. And let me know if you guys have any questions. I'll see you tomorrow. Bye.